Dear students, today we are going to look at this important topic in chemistry, which is electrolysis. What is electrolysis? The word electrolysis is coined from two words, which are electro and lysis. Electro and lysis. What is the meaning of electro? Electro stands for electricity. This word electro means electricity. Okay? Lysis here means breakdown. Lysis means breakdown. Now, what is electrolysis? Electrolysis on the whiteboard. Electrolysis here on the board is defined as the chemical decomposition of a compound which is in molten form as a result of allowing current to pass through. Look at the word. Electro means electricity, lysis means to break down. So this compound in molten form is broken down as a result of allowing electricity to pass through. The word lysis means to break down. That means anytime you hear the word electrolysis, something is broken down. And what is that is broken down in the process of electrolysis? That is a compound that is in molten form. Lysis means to break down. That means the compound here in molten form is broken down as a result of allowing current. This current is the electricity from the word electro to pass through. Okay, now when a compound is in molten form and electricity passes through it, that means that compound conducts electricity. Okay, so any compound that is in molten form and that can allow electricity to pass through, they are known as electrolytes. Okay, those compound in molten form that allows electricity to pass through are known as electrolytes. That means they are good conductors. Okay, but conductors and electrolytes are not the same. Now we are going to look at differences between conductors and electrolytes. Here we have conductor and here we have electrolytes. Let's look at the difference between conductors and electrolytes. What is conductor? Conductors are those elements that allows electricity to pass through. Okay, and reasons why conductors conduct electricity is because of the presence of free mobile electron. Okay, that means conductors here conduct electricity by the free flow of electrons. Okay, they conduct electricity by transferring electrons because electrons are always in a constant motion. They are freely moving. Okay, that is why in your textbook it is described that metals have free mobile electrons, and that is why they conduct electricity. They can easily give out electrons. Okay, and when these metals give out electrons, ions is formed. Okay, but don't forget that ions are formed when an atom loses or gains electron. Okay, when it loses electron, it's going to form a positive ion, which is described as cation ions. Okay, and when an atom gains electron, they are going to form what we refer to as anions, which is a negative ions, because electrons are negatively charged. So when they now gain electron, they are going to have more number of electrons than number of protons. We are going to discuss that in one of our next videos. Okay, the time we're going to look at atomic particles, we are going to discuss that in details. Okay, so here, difference between conductors here and electrolytes. Number one, conductors can be metals or graphites, as we have on the board. Conductors can be metals or graphite. Graphite here is one of the allotrope of carbon. Carbon, which is a non-metal. That means this graphite here is the only non-metals that conducts electricity. Okay, graphite is the only non-metal because it's an allotrope of carbon. It's the only non-metal that conducts electricity. Okay, while the electrolytes can be ions or polar compound. They can be ions or polar compound. Okay, that is point number one. Point number two, conductors conduct electricity by free flow of electrons, while electrolytes conduct electricity by free flow of ions. Okay, number three, conductors are solid. They are in solid state. Okay, while electrolytes are in molten states. In molten states, which means they are in form of semi-solid or semi-liquid. Okay, then number four, conductors conduct electricity by conduction. It conducts electricity by conduction, while electrolytes conduct electricity by convection. Is that okay? Now, having said this now, we are going to look at electrolytic cell. Now, this is a typical cell, electrolytic cell. We have here. This is electrolytic cell. This is the electrolytic cell. This we have here is a container. This is a container that contains a metallic rod or a metallic plate. This is a metallic plate. You can call it a metallic plate or rod. Then this is the semi-liquid compound which we discussed before as electrolyte, which is a compound in molten form. Then here is the battery. This is the battery. Okay, battery that has two poles. The two poles of battery here, this is the positive pole of a battery and this is the negative pole of a battery. Then the whole of this here is a switch. This is a switch. Okay, then here we have our bulb. This is bulb, which is used if you want to do test of electrolyte. Okay, if you want to test if the compound conduct electricity, look at how to do it. Now you have your container filled with electrolyte, which we can call for now as an unknown compound. because we don't know if it's an electrolyte or a non-electrolyte. Then after putting the electrolyte inside the container, you fix your metallic rod. One is positively charged, the other is negatively charged. Okay, after putting your metallic rod, then this is your wire. This is the wire. You use the wire to connect. Here is the bulb, here is the switch, then here is the battery. Then one end connect to the negative pole of the battery, and the part that is connected to the negative pole of the battery is one that is connected to the negative metallic plate. Okay, then this that is connected to the positive pole of the battery is the one that is connected to the positive metallic plate or rod that conducts electricity. Now, after connecting the whole set completely, then if you switch on, if you switch on, if you switch on the switch, all right, if the bulb glows, if the bulb glows, that shows that the compound you have here is an electrolyte, because it shows that it has conducted electricity by allowing the current to pass through. Okay, because if you look here, there is no connection between this battery and this battery except the compound we have here inside the container. Okay, so if this guy glows when you switch on the switch, okay, if it glows, the bulb glows, right, that shows that the compound we have here is a good conductor of electricity, and because it's in molten form, we can call it an electrolyte. Okay, take note, this electrolyte can be acid, base, or salt. The electrolyte can be acid, base, or salt in molten form. Okay, now we are going to look at another phase of these electrolytic cells. What I just discussed now is the test for electrolytes, the practical aspect of electricity. Now, this guy here, if this is an electrolyte, okay, let's give a typical example. It can be hydrochloric acid, or it can be tetraoxosulfasis acid. Okay, then if we are going to use salt, it's going to be sodium chloride salt, for example. Okay, it can be magnesium chloride, for another example. Okay, now if it's going to be base, for instance, we can use sodium hydroxide. Okay, then we can also use potassium hydroxide. These are the soluble base, which we refer to as alkali, because they are strong base. Okay, now this one that is positive here, the metallic rod that is positive, is called an anode. Look at the name here on the board, anode. Okay, then the negative metallic rod here is known as cathode. Okay, but don't forget that this metallic rod, the positive metallic rod and the negative metallic rod, two of them are known as electrode. Two of them are known as electrode. We have it here on the board. Okay, that shows we have two types of electrode. We have the positive electrode, which is connected to the positive pole of a battery, and the negative electrode that is connected to the negative pole of the battery. Okay, now what are we going to have next now? I don't think this is important again. Let's just remove all these so that we can focus on this. Okay, let's just remove the switch. We are now assuming that everything is connected completely at this level. Okay, now what happens is this. What is electrode? Electrode is defined as the metallic rod or plate through which current enters or leaves the electrolyte. Current will enter from here to here, and current leaves from here to here. and from there current will circulate and keep going all through. Okay, now this electrode here is defined as the metallic rod or plate through which through which current enters and leaves the electrolyte. Okay, here are the electrolytes. Current enters the electrolyte through the positive metallic plate. Current enters the electrolyte through the positive metallic plate, and current leaves the electrolyte through the negative metallic plate. And this positive metallic plate is described as anode, while the negative metallic plate is described as cathode. That is to say, these are the two types of electrode. We have anode and we have cathode on the board. Okay, anode is the positive plate, while cathode is the negative plate. As we have here, this is positively charged and this is negatively charged. Don't forget that the anode that is positively charged is the one that is connected to the positive pole of the battery, while the cathode that is negatively charged is connected to the negative pole of the battery. Now, as current is allowed to pass through, we cannot define this guy now, the cathode, as the electrode through which current leaves the electrolyte. Cathode is defined as negative electrode through which current leaves the electrolyte. Okay, while the anode is the positive electrode through which current enters the electrolyte. And this shows that currents are passing through this cathode and leave and go all around to the battery and go again and go again and come back here. Okay, now let's take this for example. Now when this is happening, we say that electrolysis is the breaking down of what? Electrolyte, when you allow current to pass through, and because they conduct electricity, they dissociate into ions. Okay, this acid dissociates into hydrogen ion and chloride ions. This is ion that is positively charged and this is ion that is negatively charged. Okay, if for the case of sodium chloride, the salt, it will dissociate into sodium ion and chloride ion. Okay, if we use this sodium hydroxide, it's going to give us sodium ion and hydroxide ion. Okay, now if you look here, you see that they have equal opposite charges. This one that is positively charged and here is negatively charged of equal charges. Okay, now this guy that is formed here, this is ions, this is also ion, this is positive ions and this is negative ions. Okay, once they dissociate in the solution, this guy, this ion that is positively charged, that is the positively charged ions, the positively charged ions will migrate to the negative electrode, while the negatively charged ions will migrate to the positively charged electrode. According to Benjamin Franklin, like charges repels and unlike charges attract, and that is also seen in Coulomb's law, which says that like charges repels while unlike charges must attract. So these ions that is positive will be attracted to the negative electrode, and at this level it is known as cathode ions. It is known as what? Cathode ions. While the ions that is negatively charged will migrate towards the positively charged electrode to obey the law that unlike charges must attract to each other, and at this level it is known as what? Anode ions. Okay, later this guy is what? Positively charged ions. Okay, while this person here is negatively charged ions. Who is that? The ions that migrate to the anode during electrolysis. It is negatively charged ion that migrate towards the anode, while the positively charged ions migrate towards the cathode. And this positively charged ion here that migrate towards the cathode, they are now given another name known as cat. From cathode, then we have ions. They are known as cat ions. That is why cat ions is described in your textbook as the positively charged ions that migrate towards the cathode during electrolysis. Okay, then here, an ions, this one here will give you an and what? Ions. And from anode, then ion is attached to the an to form an ions. And ions here are the negatively charged ions that migrate towards the anode during electrolysis. Don't forget that current flows from here and go around. That means cathode here is the negatively charged electrode through which current leaves the electrolyte, while the anode is the positively charged electrode through which current enters. That means current flows like this. This is direction of what? Current flow. Okay, then as current is flowing, this person here, these electrons are going this way. Okay, this is direction flow of electrons are negatively charged. Okay, this is direction flow of current, and here is the direction flow of electrons. Okay, now in this electrolysis, we are going to look at oxidation and reduction. Here, what is oxidation? Oxidation here is the electron loss. Okay, and this anode loses electron to become like, okay, they lose this electron. Why do they lose electron? This guy is here is the ion. These ions here, the anions are the negatively charged ion. So they're going to lose the negative charge of the ion. For instance, this, they have more electron than proton. Okay, it's going to lose this electron to become what? Neutral. Okay, and the process of electron loss is known as what? Oxidation. That is oxidation. Okay, you can say that oxidation takes place here in the anode because oxidation is the process of electron loss. Okay, and as these electrons are being lost, in the anode, these cat ions here are positively charged, so they now need the negative particles to neutralize them so that it will give you a neutral atom. Do you understand? I said the cat ions here, they are positively charged. That means they have numbers, some numbers of proton more than the numbers of electrons. So as this person here is losing electron is going to flow and come here to the ions of the cathode, which is the positively charged ions, which we describe here as cat ions. So yes, it will now gain the electron that is negative. It will balance the charge. Okay, it will neutralize it to become what? A neutral atom. Okay, something that is positively charged, that is, it has one proton, one the numbers of electrons, so it will now receive one electron. To balance this, it will give you a neutral atom. Okay, and the process of electron gain that happens here in the cathode is known as reduction. Reduction is the process of electron gains. On that note, oxidation takes place in the anode, while reduction takes place here in the cathode. Okay. Now, in the next video, we are going to look at the calculation aspect of electrolysis, where we are going to follow the procedures which is known as the law of microfaraday. Okay, this is all we have for now. Thank you and God bless you. Please don't forget to like, subscribe, and share our videos. More videos are coming. Goodbye.